first I try to demonstrate how to do the digital logic design using Verilog. I hope you all know the basic steps. Your folder may be available in document database in digital. Here create your new folder, say ALU. In this ALU, copy paste your C# file. Don't forget this step, it will reduce your lot of steps. So first copy paste C# file here, then you will have one file, that is design file alu.v, then alu test.v. so design file and test bench file. Other than that, you need to have two more files. One is input constraint, another one run.tickle. This two file is mandatory for synthesize. This run.tickle I will explain. I hope both of the files will be available in your documents. If it is not, you try to copy it in a pen drive and bring it. Before examination, you ask your system admin to keep it in the desktop. Now this run.tickle is important for synthesize. I will explain how to write this code. So first thing here, you need to read the library. This line is reading the library, and second you have to read your design file, then elaborate the design, then read the input constraint, then synthesize generic, synthesize mapping, synthesize optimize. Up to this is synthesize steps. Then you need to write the outputs. You will get the netlist, then write the output constraint. If you want to see it as a GUI, then write GUI show. Then it will create four types of report files. One is report timing, report power, report area, and report number of gates. So in case of you are writing 4-bit full adder, you will have to write here two files. One is full adder file, and another line read HDL, maybe ripple carry adder.v, whatever the file name you have to write that. Other than full adder, I hope all the programs have only this one design file. Okay, let's start how to do simulation first. First you have to navigate to the folder, check where you are. This is the folders. I need to navigate to documents. So cd documents. In documents, I think it's database. Inside database digital. Inside digital ALU. So I navigated to my folder. Now check how many files I have. I have test file, design file, C# file, input constraint file, and run.tickle. Now from here you have to launch your NC launch, CSH, then source, C#, now NC launch. To do simulation, we need NC launch tool. For synthesize, we need another tool called Genus. Now this window will get open. Now here use multi-step, click multi-step. Here first step is set the design directory. Go to file, set design directory. Here go to your particular folder, that is ALU, click OK, then create cds.lib, save, don't include any libraries. Okay. Now you will, two files will appear in your this left side window. First click one file, do simulation, compilation. Here in work directory that file will reflect, and second do the same for test bench file. Again it will reflect here. Then click design file, do elaboration, and it will reflect in snapshot. Second click test bench file, again elaboration. Now you have to click only test bench file and click simulation. You should not simulate the design file, you should simulate the test bench file. Wait for few seconds, simulation window will open. Now click here, now click right hand side window, Control A, right click in yellow side and send it to waveform window. Now after getting this window, click this play button. Now this is your simulated output. To fit it in one window, just click this equalize button. Now the ALU simulated output is visible here. If you want to change the radius, it's a hexadecimal number. If you want its decimal number, then that also you can do by right clicking. Right click, change the radix. Now this is decimal number. I hope you understand the steps of simulation. To do synthesize, close all the files. Now to do synthesize, press Ctrl C. Now make sure you are in same folder. Now you should have run.tickle in your folder. Now again launch CSH, source, C#, CSH, source, C#, now synthesize tool is Genius. Wait for few seconds. Make sure that you have run.tickle in your folder, and as I told, the run.tickle is very important. You should know how each line is working. So this is reading library, reading your design file, elaborate, read input constraint, synthesize, generic, mapping and optimize, write netlist, write output constraint, GUI, report, timing, power, area and gates. Okay. Now if you have that files and along with the input constraint file, synthesize is one step process. Command is source, run.tickle, enter. The simulation tool will take care of all the steps and it will give this window. After getting this window, just click this plus button and go to schematic. So this is your synthesized version of AL. You can see power also, report power. Okay. Now we have created four reports. Those 4 reports will be available here. You can see we have created gate report. So these many gates are used in our synthesized netlist, and we created power report. This is our power, and we created netlist. This is a netlist. Netlist is a logic gates and connection between the gates. It's called netlist. It is a hardware description of our ALU. Then power is available. Timing, since we didn't include any timing, so here you won't get any timing report after synthesize. Okay, this is the simplest step to do the simulation as well as synthesize. You need to remember the steps. That is, first create a folder, then in that folder copy C# file, then you should have design file, test file, input constraint file, and run.tcl. If you have these 5 files in your folder, getting output is 5 minutes job. I hope you understand. Thank you. If you have any doubts, let me know. I'll make a video. Thank you.